everybody. My name is Serena, and I'm a dual degree student in MBA and Environmental Management at Yale University. I'm recording this video from the Yale School of Forest and Environmental Study, and today I'm really excited to talk to you about what I believe is the future of design for plastic. So I've prepared several slides, and I cannot wait to share them with you. So here we are. So for this session on the future of design for plastic, I will structure it in three key points. So the first point is about the benefits of using plastic and why I think it's a miraculous product. Secondly, I will talk about the downsides of using plastic, and specifically from a health and environmental perspective. And thirdly, I will share with you some of my ideas on the future of design for plastic. And they will rotate around using benign materials through green chemistry principles, but also looking at the future in terms of using data sharing and modeling tools to choose designs and materials, but also thinking about tech solutions that can allow for increasing recyclability or reuse of plastic. So let's start. So let's start with the benefits of plastics and why I think it's a miracle product. So plastic today, it's used in most consumer products. And my guess is that it's around 90% or more of the consumer products that we have. And it's not just in terms of the product itself, but it's the packaging that surrounds the product and allows the product to be delivered safe and sound on the shelves. Plastic has actually experienced an exponential growth. From the 1950s, it started with 1.5 million metric tons per year, and it has reached in 2015 322 million tons per year. And it's forecasted actually by 2050 to reach 400 million tons. So you can see that this exponential growth is continuing, and it will actually be reaching a huge market size. It has been estimated for 2015 to have a market size of $650 billion. And what is incredible is that 85% of the plastic is actually commodity plastic, which is meaning that's the plastic that we find in packaging and is very cheap. So despite this very large volume and this large percentage, the market value is very, very high. So the plastic industry is certainly happy about it. Why I think it's a miraculous product is because plastic has brought so many benefits to society. First, thinking about the properties of plastic itself. It's easily shaped in whatever shape or forms we want. It's versatile, meaning that it can be used literally in any product, and that's why it has been widely spread in all consumer products that we find today. It is a strong material because it can carry liquid, it can carry very heavy materials, very heavy contents, and still hold strong, but yet is a very, very light material. So conversely to plastic, it's a super convenient material to use, also because it's inexpensive. It has also the properties to be sterile if you want to. So for instance, we can use it both for packaging meat and preserving meat for a long time, but also for using it in healthcare applications. And so thanks to plastic, we have improved our hygiene standards and also our healthcare standards by a lot. However, what we have to know, and something that I realized myself, is that plastic cannot exist without without additives. So plastic otherwise would be very brittle and would not be able to perform all the functions that it's able to perform today. And what do we mean by additives? So when I was studying additives, I actually realized that there are so many in the market, and there is a book very, very thick that enlists all the additives that go into plastic. But I have grouped several here, and the list is not exhaustive. And I'll go through it so that we can have a better understanding. But in terms of plastic additives, the major the major ones are plasticizers. Plasticizers are the building blocks of plastic and are able to make plastic what it is. So here I've made two examples, which is PVC pipes and cling film. Both these two wouldn't be able to actually exist without plasticizer additives. So for PVC pipes, it is estimated that around 40% of the weight is made of plasticizers. And cling film, just because of the nature of and the functionality of this material, it's actually a very large percentage is actually plasticizers. Other type of additives are light stabilizers, antioxidants, antimicrobials, and flame retardants. All of those are used ad hoc depending on the function that the polymer has to perform. So we will not find flame retardants into food packaging, but we might find antimicrobials, antioxidants, and light stabilizers in some food packaging or some cosmetic packaging, depending on exactly the function that those packaging or that plastic has to perform. However, what I also found from my research is that plasticizers and several other additives are used beyond plastic. And since the 70s have been added, as the word says, more and more into the ingredients of consumer products themselves. So they can be found in cosmetics, they can be found in detergents, in cash receipts, and in cans. So for instance, I put here two key examples of lipstick. So we find plasticizers in lipsticks, in shampoos, in creams, but also in the cash receipts, because it's paper that is actually impregnated with BPA, and the dark text that we see, it's not ink, but it's actually burned BPA. So well, after having enlisted to you what are additives and where we can find them, I think we should move on to the downsides of plastic. So for me, the key downsides are health and environmental effects. So from the standpoint of health, the key downsides that I found is that plastic components and plastic additives specifically have effects that are in carcinogenic terms. They can cause internal organ damage, and they can cause endocrine disruption. However, it's very easy to say this and very scary to say this at the same time. So it's really important to have an understanding of why and how they might actually cause these downsides. A very important way to understand that is to understand how, in toxicological terms, we define risk. So risk is defined by hazard times exposure. Exposure, it's actually what I think is the how we can define it in toxicological terms, in migration of additives and building blocks of polymers of plastic from the plastic itself to the content or to whatever surface that the plastic gets in touch with. And by absorption, we mean how that gets absorbed by our body, so how it becomes bioavailable. And then hazard is actually the toxicity of each single compound, because not all compounds have the same degree of toxicity. Not all elements in nature have the same degree of toxicity. Actually, those makes the poison. So everything can be toxic in nature. Even water might be toxic depending on how much we drink of it and at how fast we drink it. So anything can be lethal. However, what I've found from my research is that plastic can be, of course, causing all these downsides, and the migration of compounds from plastic onto whatever material they get in touch with, it's dependent on not only the type of polymer, but also several environmental conditions. So, for instance, if the material that plastic gets in touch with is greasy or fatty, or if there's been swings in temperature from hot to cold to hot, or just hot, the migration happens a lot faster. And so it's very important to be aware of this, because that means that, for instance, if we have hot soup in a plastic bowl, the chances that we have absorption of those compounds from the plastics are a lot higher, conversely, on if we were to drink that soup cold. Also, what is really important to know is that there's a lot of those compounds that we metabolize and we excrete on a daily basis, but are also compounds that get bioaccumulated, meaning that they get stored in our fat cells and they stay with us. And that is why they have all the downsides that I mentioned here above, because they might also stay with us for a long time and have intergenerational changes. So for instance, if I absorb and metabolize and store in my fat cells some endocrine disruptive elements, well, it might be that those have effects on me, not only me, but also onto my babies and my grandchildren. So this is very important. Beyond the health downsides, there are also environmental downsides of using plastic and disposing of plastic. We have a lot of awareness when it comes to, of course, plastic in the ocean, and definitely these are extremely important issues. However, what I want to highlight is something that is less known, which is basically when plastic degrades, both in, or what plastic additives are absorbed by us and excreted by us, or when plastic degrades in the environment, there are a lot of externalities that happen in terms of just those additives. So the first on the list here is aquatic life and wildlife impacts. So for instance, there has been studies that I've read about where BPA or other plasticizer additives or other additives in high concentration have been proven to actually change the sex of fish. There are many other downsides that happen to aquatic life. So for instance, the first picture here to the left shows that this fish has had a lot of exposure to BPA, and actually its internal organs are exploding basically, and that's why the fish died. Something else that we need to be aware of is that when plastic degrades, there are all these additives such as BPA, and which is very known, and the like, that can be absorbed by the soil, and therefore it can also be absorbed by plants and by forests when it degrades, and even more so if it's carried by water. And that can go back to the food chain. Also, something that people might not realize is that all these additives cannot really be filtered out by conventional water treatment plants or by sewage treatment plants, just because of the nature of these compounds. These are very tiny compounds, and therefore filtering them out is very difficult, if not impossible. Only reverse osmosis would have the power to filter out this type of compounds, but as a very costly technology to implement in simple water treatment plants. And normally everything gets treated with chlorine or ozone. So if, for instance, once the sewage has been treated, sometimes sludge is used as fertilizer, and there's been research that have found that all these additives such as BPA, and I keep on mentioning BPA because it's one of the most known ones, has been found in sludge that is being used as fertilizer for agriculture, and therefore it has been absorbed by plants and can go back into the food chain. Other issues that I want to highlight in terms of these additives that are used in plastic is related to waste management. So what I found from my research is that whenever there is the collection of plastic for recycling, during the collection and phase and the transportation or the management on the waste management sites, there is cross-contamination of those additives between specific types of plastics. So for instance, PVC, as I mentioned earlier, is a type of polymer that has a high additives content. So it has been found that a lot of those additives might migrate from PVC to other types of plastics. And the causes are unknown, but it might also be that it depends on the moisture level. It depends on the maybe grease level that certain type of plastic might have because they're not clean. So migration might happen, or even temperature. So these are some ideas that I might have for why cross-contamination happen. There are also issues that I've researched in terms of recycling. So this is a very very important topic, because recycling is a really important measure for mitigating, reducing our impact of plastic use on Earth today. Globally, we recycle around 9% of plastic, which is a very little amount in comparison to all the plastic that is made, as I mentioned earlier. However, something that I found out from my research is that whenever we recycle plastic, and specifically for mechanical recycling, which is the methodology for which majority of plastic is recycled, we actually increase the percentage of additives in the plastic itself, because mechanically we break the plastic, as shown on the picture to the right, and basically we reblend it together. But to reblend it and to have still good performance, we need to add some of those chemicals that I mentioned in my second slide. Other issues related to managing plastic from a waste perspective is in terms of incineration. So by looking at reports or studies about the way about VOCs or other pollutants that gets released when plastic is incinerated, it's actually staggering how many toxic VOCs can actually be released by plastic. So thankfully, many advanced incineration systems have filters, very strong filters that act as barrier to prevent the release of those fumes from the incineration. However, not all incineration facilities around the world have this state-of-the-art filtering system, and therefore we do have in many parts of the world the release of those VOCs from plastic when it gets incinerated. Also, it's important to note that a lot of plastic, especially in the developing world, gets incinerated on the street or gets incinerated as a way for fuel, and therefore people get directly exposed to that plastic and inhaled the plastic incineration VOCs, and that causes a lot of environmental and health damage. A majority of the plastic also gets a large part of the plastic also gets dispersed in the environment, as we know, and specifically we know about plastic gets dispersed in the ocean, and that's a huge problem. Something that people have started to realize is that plastic gets broken down, and its degradation leads to plastic to be in very small particles, basically microplastics, and these leaches substances into the environment. Something that is also very important to know is that when plastic is in the ocean, it acts as absorbent material. So whenever there is strong pollutants or that come from oil spill, or that comes from maybe dumping from boats, or whatever accidents that might happen in the ocean, plastic becomes this absorbent body that actually carries those pollutants around the ocean. And that's why also the recovery of marine or ocean plastic is very hard, because it might be very toxic, and it might be very difficult to find uses for that plastic that is being in the ocean for a long time. So with having said all of these issues in relation to plastic, and this is just from the research that I've been conducting in the last years, I now want to move on to a more positive note. And brainstorm what ideas might be for the future of plastic design. And these are just some ideas that are not all mine. They're ideas that I have, discussed with people here at Yale or with people that I have met from my research journey. And I would like to share them with you and hope that you will be able to reach out to me and discuss with me these ideas. So the first one, which is something that is very dear to my heart and related to the topic of green chemistry, is about changing materials. So as a consumer, what I have been doing and what I hope for you to do, it's to avoid plastic whenever possible, and especially for hot or greasy food. And this is because it's the primary route of exposure to plastic compounds. So for instance, if you want to drink water from reusable and use reusable bottles, just maybe use glass or stainless steel water bottles rather than plastic, because even if they say BPA free, well, BPA free might actually have BPS, which might be even worse than BPA. And cases of regrettable substitution exist everywhere, and therefore we don't know whether BPA free is truly safe. So my advice to you, from consumer to consumer, is to avoid plastic whenever possible, especially in relation to food, because that's the primary route of exposure as a consumer. As a producer, my hope is that whenever you think about delivering a solution to consumers, you would think about using benign materials and thinking about what additives go into the plastic that you use. So, for instance, you might use the conventional polymers, but find that specific formulations or polymeric structure that do not require as much additives as conventional designs and formulations currently do. And that might require changing the design of the packaging or design of the plastic product you want to deliver to consumer. And this is a conversation that, of course, needs to happen with marketeers, with R&D, and with product designers. But solutions are out there in material science and in chemistry. And you can work with material scientists to figure out what type of plastics can deliver this and perform the same function while using less additives, and therefore being less toxic for your consumers. There are also alternative materials, completely alternative materials that are plant-based polymers, such as PLA. Or I have put this image on the right about plastic made from algae. These are, of course, solutions that are not perfect because, for instance, PLA, it's not degradable. Fully degradable, is compostable on a controlled environment, and the issue is that it might cause white pollution. It might induce consumer to think that PLA can be just thrown on the street and it's going to degrade by itself. Definitely that might be a problem. PLA also gets confused with in the recycling stream for PET and creates impurities in the recycling stream. So there are issues in relation to the change of materials, specifically when it comes to choosing completely alternative materials. But there is our conversation that could allow for a reshift in the design, and in the end product that you push out to the market. What is really important to know is that there are benign plasticizers or benign additives that are currently developed in the market and already replacing the conventional additives with the benign additives is a huge step forward in terms of ensuring consumers' health. It doesn't make a huge step forward in terms of environment, but at least it allows to lower the impact in terms of human health and animal health. So my overall recommendation in terms of the change material solution is either work with green chemists or follow green chemistry principles. And these principles can be found online. You can just Google green chemistry principles, and you will see that these are all principles that from a design standpoint, when choosing materials, are really important to follow because they basically embrace the environmental and health issues that are all at our heart. The second solution, the second idea that I've been thinking about is, what if there was a way to share data and share modeling tools to figure out what best practices and ideas can be created for materials, formulations, and design to create products that are safe for health and the environment. This data sharing and modeling tools platform could basically store information about environmental impacts of different products, different packaging materials, and those could be standardized through life cycle assessments or through other environmental assessments, and could store information also about the health impacts of different products, and that could be done through standard migration testing, toxicology testing, and simulation models on the impact of these materials. Something that I was tracking about when I was looking at both REACH and the ICHA model is that these are regulation driven, especially in the European Union. ICHA is this data sharing platform for companies to share information about chemicals and the chemical testing. However, something that it would be great to add to ICHA is potentially this open source platform where people who are looking at creating a new product or would like to test a new formulation can access information in terms of what best practice has already been created in terms of having a safer product for consumers or for the environment. And for me, when we are able to share information, we're able to have a leapfrog in terms of finding products or finding solutions that are best for consumers. And so this is something that I came to bring to you because I realized that there's a lot of information secrecy when it comes to the additives that are put in plastic. We don't know the exact formulation. So it's something that in a way, it's really important for consumers to know, because why do we have ingredients for what's inside the product, but we don't have ingredients for what surrounds the product? We don't have ingredients for exactly what type of plastic we're touching or we're using to eat. And there's the assumption that plastic is safe, but it's actually not. So if we could have a data sharing platform, also we as consumers would be able to have information in terms of what type of plastic would be best to use. And that would be really important to inform designers as well. And then the third solution that I have come up with also through my research and speaking with people is about the use of technology to improve recycling or also enabling the reuse of plastic. So there are many technologies that have been developed in the market, such as conductive or invisible ink, or also recognition technology. And what they could be enable is actually the access of information in terms of what specific polymer is in that packaging or in that product, what specific additives are in that product, but also what is the who is the producer in terms of the plastic, or who is the producer in terms of the manufacturer of the product itself. So what I think it would be enabling us to do by using this technology is to have an increase in increase in information and an increase in a step up in the way in which plastic is managed today. Currently, the way in which plastic managers separate plastic is through infrared technology or even manual sorting, depending on the country. So Europe is more on infrared, whereas in the United States is more manual sorting, and the developing world is actually trash pickers or also manual sorting. So if there were to be an investment in this technology, it would actually allow to improve the recyclability, just because through this either recognition technology or through invisible ink or conductive ink, it would be, for instance, an invisible ink, you would have a product and it would be is not visible to consumers, but is visible to a specific light, and it would enable the access of a lot of information on, for instance, the packaging or on the plastic product. And a machine would be able to have a better understanding of what exact type of polymer it is and who the producer is, and potentially this could allow for precise sorting. So what if it would be able to have precise sorting? That would mean that the plastic managers would be able to actually have an exact capturing of, for instance, how many bottles are made by a precise producer, what is the condition of the bottle, what type of bottle it is, for instance. And so the waste managers will be able to feed information back onto that bottle producers, for instance, or that brand. So what a consumer packaged good company. And for instance, say, look, we have X ton of this type of packaging for this product. Would you like it back? And maybe you can either, sanitize it and rewash it depending on the condition, or you can just use exactly that same polymer and basically recycle it in a way that is more pure, enhancing the value of that polymer and actually potentially be able to use less additives. So this would allow to either close the loop or make the loop a little bit better when it comes to either the recycling or the reuse. And that would allow to enhance the sustainability of companies and also be able to have a better understanding of how we use materials overall. So these were my 3 solutions. I hope you liked my webinar and the ideas that I had in terms of enhancing packaging or plastic design. And I really thank you a lot for your time. And if you have any questions, please email me. My email address is serena.pozza@yale.edu. Thank you so much for your time.